These haunting images have lingered in the public's mind following the devastating 7.7 magnitude earthquake that struck Myanmar. Many people are surprised that such a massive earthquake could even occur in Myanmar. In fact, global disaster researchers estimate that its destructive power was equivalent to 3,000 Hiroshima nuclear bombs. This earthquake originated from a fault line known as the Sagaing Fault. So how did the Sagaing Fault form and lead to earthquakes? The Sagaing Fault is a right lateral strike-slip fault approximately 1,200 kilometers long, running north-south through central Myanmar. It marks the boundary between two major tectonic plates, the Indian Plate and the Sunda Plate. These two tectonic plates move in opposite directions at a rate of approximately 18 millimeters per year, generating stress accumulation along the fault. When the stress surpasses the rock's threshold, it is released in the form of an earthquake. How dangerous is the Sagaing Fault? Myanmar is situated in a geologically complex region at the convergence of major tectonic plates, including the Indian Plate and the Eurasian Plate, which encompasses the Sunda microplate. One of the most significant geological structures in the region is the Sagaing Fault, a strike-slip fault approximately 1,200 kilometers long, running north-south through central Myanmar. This fault marks the boundary where two tectonic plates slide past each other at a rate of about 18 millimeters per year, generating substantial geological stress. Over the past 500 years, the Sagaing Fault has triggered approximately 70 major earthquakes with magnitudes of 7 or higher on the Richter scale, including the strongest earthquake, which reached a magnitude of 8 in 1912. Notably, this fault is especially dangerous as it passes through several major cities, including Mandalay, Naypyidaw, and Taungoo, placing millions of people at high risk in the event of an earthquake. This earthquake not only caused severe damage in Myanmar, but also sent tremors across neighboring countries such as Thailand, Vietnam, and China. Impact of the Myanmar earthquake on the 7.7 magnitude earthquake that struck Myanmar on March 28, 2025, with its epicenter near the Sagaing Fault, not only caused extensive damage within the country, but also had significant impacts on neighboring nations, particularly Thailand, as well as others including Vietnam, China, India, and Bangladesh. Thailand, particularly the capital Bangkok, experienced noticeable effects despite being about 1,300 kilometers from the epicenter, due to the shallow depth of the earthquake, 10 kilometers, and the region's geological characteristics. A 30-story building under construction in Bangkok's Chatuchak district completely collapsed, trapping at least 43 workers. Over 70 individuals were found either alive or deceased beneath the rubble. Initial damage estimates reach into the millions of USD. The State Audit Office, SAO, in Chatuchak district collapsed, and 169 other buildings in Bangkok sustained cracks, although their main structures were not severely affected. In Mae Hong Son province, northern Thailand, at least 6 sinkholes appeared, ranging from 2 to 30 meters in diameter. These were concentrated along the Mae Hong Son Fault, posing safety risks to local residents. Several rooftop swimming pools on high-rise buildings in Bangkok overflowed due to the intense shaking, creating waterfall-like effects cascading down the sides. At least 10 people were killed and 16 others injured in Thailand, primarily at construction sites in the Din Daeng, Bang Su, and Chatuchak districts. Over 100 people were reported missing in the building collapse incidents. Countries such as Vietnam, China, India and Bangladesh experienced milder impacts, mainly limited to shaking in high-rising buildings without significant damage. The widespread effects were driven by the shallow depth of the quake, its strike-slip mechanism, and the presence of soft soils in lowland areas that amplify seismic waves. This event highlights the urgent need to improve earthquake preparedness and regional disaster response coordination to minimize future risks. Many people are curious as to why such a large earthquake was not predicted in advance. The reality is that seismology has not yet advanced to the point where it can accurately predict the time, location, and magnitude of an earthquake. Although scientists can identify high-risk areas, such as the Sagaing Fault region in Myanmar, they can only provide long-term risk assessments, not specific predictions. Furthermore, earthquakes occur when accumulated pressure within tectonic plates is suddenly released. This process depends on many complex factors, such as the strength of the rock, friction between the plates, and small changes in the Earth's crust, which are very difficult to measure directly. This earthquake occurred along the Sagaing Fault, an area known for its high risk due to the strike-slip motion between the Indian Plate and the Eurasian Plate. This is a type of earthquake that develops a portfolio of scarcities, catastrophic weather. Seismologists have identified this as a seismic gap, an area that has not experienced a major earthquake for an extended period, allowing significant pressure to accumulate. However, determining when this pressure will be released is nearly impossible. History of the strongest earthquakes in the world. Although considered a strong earthquake in recent decades, the earthquake in Myanmar is still regarded as milder compared to some other major earthquakes. One notable example is the Valdivia earthquake, which occurred on May 22, 1960 in Chile. It reached a magnitude of 9.5 on the Richter scale, with its epicenter located at a depth of 33 km. The earthquake triggered a tsunami that reached heights of 25 meters, affecting Chile, Hawaii, Japan, and the Philippines. Approximately 1,600 to 0 people were killed, 2 million were left homeless, and the economic damage was estimated in the billions of USD, based on the value at that time. Many cities, such as Valdivia, were completely destroyed. In comparison to Myanmar 2025, the Valdivia earthquake released energy thousands of times greater, 9.5 on the Richter scale versus 7.7, with damage spreading across multiple countries due to the tsunami. However, the death toll in Myanmar is higher due to the larger population density and poorer infrastructure compared to Chile at that time. The most recent earthquake in Turkey is considered to have many similarities with the earthquake in Myanmar. At around 4:17 AME local time on February 6, 2023, a 7.8 magnitude earthquake struck southern Turkey and northwestern Syria, shaking the region. This was also a shallow earthquake with a depth of 17.9 km. The earthquake resulted in over 55,000 deaths, 50 in Turkey, 50 in Syria, tens of thousands injured, and millions left homeless. Over 100,000 buildings collapsed or were severely damaged, including homes, hospitals, schools, and industrial facilities in Kahramanmaraş, Hatay, and Aleppo. Many cities were leveled. What is the forecast for such disasters in the future? It is predicted that regions such as Japan, Indonesia, Myanmar, and the Himalayas are at the highest risk of earthquakes due to their location on active fault lines. Major earthquakes in densely populated regions such as Southeast Asia or the Himalayas could result in tens of thousands of deaths, similar to the 2023 Turkey-Syria earthquake, 55,000 people. Weak infrastructure and rapid urbanization in countries like Myanmar, Indonesia, and the Philippines increase the risks. Earthquakes in subduction zones, such as Japan and Indonesia, carry the risk of tsunamis, causing damage far beyond the epicenter, similar to the 2004 Indian Ocean earthquake, 230,000 deaths. In addition, earthquakes can have widespread effects. As the Myanmar 2025 earthquake showed, tremors can cause building collapses in Thailand and disrupt transportation in Vietnam. Future earthquakes in Southeast Asia will likely have similar effects, especially in cities with soft soils like Bangkok or Ho Chi Minh City. The recent earthquake in Myanmar also highlighted the severe impacts when an earthquake occurs in densely populated areas with weak infrastructure and political instability. While waiting for scientific advancements, mitigating risks through earthquake-resistant construction, early warning systems, and community education is the most effective way to cope with future earthquakes.